We are on section 1.3. So we're just combining everything that we figured out so far. So that's not too bad. So we've done shifting up and down, shifting left and right. So that's like a vertical translation, a horizontal translation. Then we did reflections on the x-axis, reflections on the y-axis, and we also did stretches, horizontal and vertical. Okay, so that's what we've done in the last two lessons. This is doing everything together. So what I did on the top of your notes is I wrote what an equation would look like if it had everything. Okay, and then we're just going to define what all of these pieces means, just so we have it all in one spot. Okay, so this guy here, oh, help me, there we go. He's a vertical stretch. Okay. Okay, if he's negative in front, that means that that is a reflection on the y. No, reflection on the x-axis, sorry. It changes your y's. Okay, so if A happens to be negative, that's a reflection on the x-axis. So you might want to say, like, change y's, just so you remember for yourself. This guy, I should be writing in different colors. He's a vertical stretch. Okay, so if he's 2, your y's are 2 times as big. If he's a half, your y's are half as big. Okay. This B here, this is our horizontal stretch, because anything that's happening within the brackets is affecting our x. So this is a horizontal stretch. And we need to remember that what happens in here is the opposite. So if B happens to be a 2, your x values are half as big. Okay, so I'll just put a little example here. B equals 2. Okay, so this affects your x values. Also remember, if B happens to be a negative, then that's a reflection on your y-axis. So if B is a negative, your x values change to opposite sign. And we call this a reflection on the y, meaning your y-axis is the mirror. Okay. Then we got to h over there. H is in the brackets with x, so that is a horizontal shift. Okay, and again it's going to move the opposite. So if h is negative, we're going to move to the right, positive. And if h is positive, we move back to the left, negative. Okay, so this guy is a horizontal shift. So if he's positive, you're moving, what did I say? Left. If he's negative, you're moving right. Okay, so then if we have K, okay, so we were talking about K is your vertical translation. So this is where you're moving up or down. So if K is positive, you're going up. If K is negative, you're moving down. Okay, so this is everything that can possibly happen in one equation. Okay, we've just put it all together and mapped it in this. So it's not too bad once you write it all out and you can see it, right? Okay, let's move to an example. This part also drives me crazy. Which one, this one? Okay. Okay, so example 1. Graphing a function. So, it says describe the combination of transformations that must be applied to the function to obtain the transform function. Then sketch the graph. Show each step of the transformation. Okay, so when it says show each step, that's when I said you could either show each graph as it moves, which gets confusing to me, or you can show each table as you change it and then one picture. I prefer the table, then we won't get lost as much. Bo, can I erase that? Perfect. Okay, so when we're looking at A, it says y is equal to 3 and then f bracket 2x. Okay, so we need to say what is happening first in this. What's at 3 to start with? It's a what? Yeah, so it's a vertical stretch, right? And it's going to be of 3. We don't have a reflection because there's no negative. And then what about that 2 in the bracket? Yeah, he's a horizontal stretch. Right. So he's actually making it smaller. He's compressing it to a half. Okay, so before I start graphing all the points here, let's do B also. If you notice, we have a 3x plus 6 in there. It's never good to have that 3 in front, so you should bring them out first before you start. Okay, so because we could simplify in here. So our equation would actually look like if we divide it out by 3, you would have a bracket, and then you'd have 3x plus 2, and it would look like that. Okay, so this being, that would be a horizontal stretch of a third, and this would be what? Yep, a horizontal shift to the left 2, right? -2. We could put negative there. Okay, so that's our description of what's happening. If we actually want to graph what the new pictures look like, what we can do is we'll just make our table of points and then change them. Okay, so I'm just going to try to move this down. Okay, so our points, our original ones, are on our graph right there. They are 0 and 0, 1 and 1, 4 and 2, and 9 and 3. Anybody recognize what that kind of graph is? What the equation is? It's actually a root equation, is it not? Because it starts here, or whatever, goes up that way. So these are our original points, and then what we're going to do is we'll do for A what happens to it. Oh, and a key you probably want to write on those notes back where we just did the whole equation. Write with a little star. We always do stretches or reflections first, and then we do translations after. Okay, so that's kind of like the bed mass of how to figure it out. So always do reflections and stretches first, and then do any moving left or right, up or down. Okay. So in this situation, we have 2 stretches, so it doesn't matter which we do first. We'll just do one and then the other. So I'll just put my table here. It's going to be kind of in the way, but So remember in the first one we had a vertical stretch of 3, meaning our y's all get multiplied by 3. So I would times all my y's by 3. So now I still have 0, 3, 6, and 9. And then this 2 makes all my x points half as big. So I'm just going to take all my x points and divide by 2. Or multiply by half. Whatever floats your boat. Okay, so that's 0. 1 divided by 2 is a half, or 0.5. 4 divided by 2 is 2. And 9 divided by 2 is 4.5, or 4.5. Okay, so those are our new points. And if we wanted to graph it, all you'd have to do is go on your graph and go 0, 0, half, and 3, and then 2, and we're all the way off the graph already. So it's kind of going like that, way up. Okay, and then our other table for part B is we have a horizontal stretch and we have a translation. So this is a point where we would stretch it first, or technically compress it because we're doing a third. So we stretch it and then we're going to shift it. So nothing's actually happening to our y's in this situation. So our y's stay as the original y points. 0, 1, 2, 3. And what's going to happen to our x's is we're going to divide them by 3 first. So 0 divided by 3 is 0. 1 divided by 3 is a third. 4 divided by 3 is 4 thirds. And 9 divided by 3 is 3. Okay, so we're not quite done yet because we still have to add or subtract 2 off of all of that. Okay, so I'd make my next table. And again, my y points did not change. And then I'm going to subtract 2. So minus 2, minus 2, minus 2, minus 2. Okay, and just for fraction's sake, I'm going to think as minus 2 as minus 6 over 3, just so that they go easier. So my minus 2 is the same thing as minus 6 over 3, because minus 6 divided by 3 is minus 2. Okay, so 0 minus 2 is minus 2. So then I have to think 1/3 divided or subtract 6 over 3 is negative 5 over 3. You can do this on your calculator too. 4 over 3 subtract 6 over 3 just gives us with a negative 2/3. And then we have 3 subtract 2 is 1. Okay, so these would be our final points that we graph. Okay, so in this situation we had an original set of xy, then I changed it, and then I changed it again to get my final. And then I could graph those points on that graph. Okay, so we'll move on to example 2. And we'll just kind of do it quickly because there's nothing new or groundbreaking here. Okay, so example 2 says combinations of transformations. Show the combinations of the transformations that should apply to the graph of the function x squared in order to obtain the graph of the transform function g of x equals negative a half to x minus 4 plus 1. Okay, so all we're going to do is basically describe, because it says write the corresponding equation, but they just told us the equation, so we don't need to write it. So let's just go step by step on what's happening here. We have a negative in front. What's that? Okay, reflection on x-axis. Okay, we have a half in front right here, so that is a vertical stretch, which is just going to shrink it of a half. right? Okay, now we have a 2 in here. That, yep, a horizontal stretch, also of a half, right? It's going to make your x's half as big. Now we have a -4. So that is a horizontal translation of +4 to the right. Okay, and then our last thing is a vertical translation of +1 up. Okay, so that's how you would break down the equation and explain the transformations. And then we'll do the last example here. And the last example is taking the graphs and making an equation from it. Okay, so we have the original is the blue graph, so the wide one, and the new transformed graph is the red one. So what we're going to do is, what I always start with is I write out the equation, and then I'm going to fill in the pieces. Okay, so this graph is an absolute value graph also, right? Because it's the V shape. And then what we need to do is, let's look, is there a reflection of any type on here? Doesn't look like it, right? Because nothing's like down or, okay, so there's probably going to be no negatives in here. Do we have, is it stretched vertically? Like, is it taller? Okay, so this is where we should start. So then, let's look. It's 1, 2, 3, 4, 5, 6, 7, 8. And this one was 1, 2, 3, 4. Okay, so the original was 4. The new one is 8. So what happened? Yeah, so it vertically stretched 2. So our A is 2. Okay, I'm probably going to throw absolute value signs in there, but it doesn't really matter because they have this equation. So we can forget about those if we want. Okay, so our B is, did our picture get wider or skinnier? Skinnier. Okay, so that's affecting, so that's like a stretch, horizontal stretch. There we go. Okay, so let's count it out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. So this is, it was 8, now it's 2. Okay, so it's a quarter the size, so what do we put for B? What's that? 4. Right. Because in there it's the opposite, right? So if 4 is in there, that means it's a quarter the size. Okay, now, did it move left or right? Okay, so it moved to the left, so it should be a positive. And then how much did it move? 1, 2, 3, 4, 5, 6, 7. Okay, so it moved 7 over. And yeah, it was there, and now it's 2 up. So +2. So that should be our equation all filled in.